Like for so many other chemistry problems, we're going to want to start with a balanced equation for the reaction that's happening. We have our acid, which is neutralizing and being neutralized by the base, sodium hydroxide. What's happening is the H plus from the hydrobromic acid is seeking out and bonding to the OH minus from the sodium hydroxide and forming water and a salt. Neutralization reactions almost always form water and a salt. And the most important thing we've found out from this balanced equation is that there is 1 mole of acid reacting for every 1 mole of base. So they react in a 1-to-1 molar ratio. This means that however many moles of acid are reacting must be the same as the number of moles of base that are reacting. So if we find the moles of acid, that'll be the same as the moles of base. So let's find the moles of acid that we have. A little slip there. I mean the moles of base that we have. The sodium hydroxide is our standard here because its concentration is given. So we will find the moles of base by using the equation we saw in the last video. Number of moles equals molarity times volume. And volume has to be in liters. And molarity is given as 0.234. And the volume is 25 milliliters, but we need that to be in liters, so we're going to move the decimal point 3 places to the left and come up with 0.025 liters. And that gives us the moles of sodium hydroxide. Now, we found out from the balanced equation that the number of moles of sodium hydroxide must be equal to the number of moles of acid if the reaction has completely neutralized the acid and no further. So now we have a sample of HBr. We know the number of moles that are in it, and the question tells us the volume that it takes up, which is also .038 liters. So now we have the number of moles in the sample, we have the number of liters in the sample, so we can easily find molarity because molarity is moles per liter.
Made with Doodlecast Pro.